Hello,
Ooh.
and welcome to my session. My name is DeAnn Huinker, and I'm from the University of Wisconsin-Milwaukee. I'll be talking with you today about aiming for deeper learning in early mathematics. Please remember to download my handouts from the resource space on the website. And following my presentation, I'll be responding to your questions in the chat space for the live Q&A. Now, let's go ahead and get started. All children have the potential and deserve the opportunity to learn important mathematics deeply. We will begin this session by grounding ourselves in the 4 key recommendations from the National Council of Teachers of Mathematics. Then we'll examine the predictive power of early math learning. After that, we will look at examples of building deeper knowledge of number, and the session will close with a summary of key takeaways. In 2020, NCTM identified 4 key recommendations for catalyzing change in early childhood and elementary mathematics. The first recommendation is to broaden the purposes of what we expect in learning mathematics. Not only do children need to learn math content, they also need to, lots of opportunities to experience the wonder, joy, and beauty that is mathematics, and to also see the world through mathematical eyes. The second recommendation is to create equitable structures in mathematics. This requires us to identify, disrupt, and dismantle inequitable practices that limit opportunities for each child to fully engage in learning mathematics. The third recommendation is about mathematics instruction. That it be guided by the 8 research-informed teaching practices identified by NCTM, while also nurturing positive math identities and strong agency in our learners. The fourth recommendation to develop deep mathematical understanding is our main focus in this session. It is important to keep in mind that the ultimate success of math programs are children with confidence in themselves as doers, knowers, and sense makers of mathematics. NCTM points out that too often the development of conceptual ideas is rushed. This results in gaps in children's math understanding that have long-term negative consequences. I often wonder, why are we in such a rush in mathematics? We rush children to memorize basic facts and procedures, we rush them to algebra, and then we rush them to calculus. This rushing only harms children in the long run and often pushes them out of mathematics rather than inviting them in. A colleague of mine likes to say we need to go slow to go fast. In other words, we need to slow down and go deep with conceptual ideas, particularly in early mathematics. We know that early math has strong predictive power. How strong? Well, in a set of landmark studies with thousands of children, mathematical knowledge at about age 5 not only predicts later mathematics achievement, it also predicts reading achievement. Yes, reading achievement. As expected, early math predicts later math achievement, early reading predicts later reading achievement, and the findings show that early math also predicts later reading. Subsequent research is finding that this is likely due to the strong correlation of mathematical work and the development of executive functions in children, such as developing cognitive flexibility, being able to hold and work with ideas and working memory, and aspects of self-regulation, such as perseverance and focus on task. So we know that knowledge that children bring into school is important, but the learning gains that children make in kindergarten and first grade is even more important. In fact, these gains are more predictive of later math achievement, even into high school. So these findings highlight the need to prioritize early math in these grades, not only for the children themselves, but also for the professional development of their teachers. So what specifically seems to be making the difference in early math? In particular, findings show that it's early numeracy that is more predictive of later math ability than other areas. And specifically, it is advanced number competencies that are most predictive. So what are these number competencies? Basic number competencies include probably what you would expect: verbal counting, one-to-one correspondence, recognizing numerals, and something called perceptual subitizing, which we will get to in just a moment. Advanced number competencies then include counting objects with cardinality, and that means understanding that a number names the size or magnitude of the entire set of objects. Advanced number competencies also include being able to count forward or backward from any given number, and it includes the ability to engage in conceptual subitizing. Some of you are likely wondering right now, what is subitizing and what does it have to do with number knowledge? We're going to examine this ability of subitizing for the remainder of this session and highlight it as not only being important, but necessary for developing deeper knowledge of number in our young learners. So, what is subitizing? I'm going to show you some dots and I want you to answer two questions. How many dots do you see in total and how did you see them? Here we go. I suspect that most of you just immediately knew there were 3 dots. You didn't have to count them, you just saw the quantity and knew it was 3. This is an example of perceptual subitizing. Let's try another one. Again, how many dots in total and how did you see them? For this arrangement, some of you might have seen 6 dots on top, like a dice, and then 1 more for a total of 7. Or perhaps you saw 3 dots in that middle column and then saw 2 in each end. Identifying subgroups like this and then putting them together is conceptual subitizing. So to recap, perceptual subitizing is quickly recognizing the cardinality of small sets without having to count those objects by ones, whereas conceptual subitizing is seeing and combining subgroups. I'd like to share a comment with you from a kindergarten teacher with whom I was working. She stated, "In 30 years of teaching, I had never heard of the word subitizing, but when I was introduced to it, it was a light bulb moment for me. I came to understand that children who are able to subitize become more flexible with numbers in putting them together and taking them apart. And it's that flexibility that prepares children for more complex work with computation." Let's think a little bit more about the role that subitizing plays in developing deeper and more flexible knowledge of number. I have another set of dots for you. Again, how many dots and how did you see it? With this dot arrangement, I first saw 3 dots on the left and then 3 on the right, and then I saw 1 in the middle. Sometimes people notice a group of 5 dots in the middle, like a dice, and then 1 dot in each side. Perhaps you saw subgroups in yet another way, or maybe you just counted them all very quickly by ones. The point I want to make here is that in our schools and early childhood programs, both counting and subitizing need to be considered essential skills for children to develop. To quote Doug Clements, subitizing is underappreciated. It is often a neglected quantifier in children's learning. It's still left out of many math programs, and many teachers are still not aware of its importance. We need to acknowledge that counting and subitizing are both essential skills as they support each other in children's learning, but they are very different processes in the way they work. Counting focuses on seeing and thinking ones, making note of each individual item. Subitizing focuses on seeing and thinking groups, looking for and seeing parts of numbers. We are going to watch a video clip of Liam and Gavin playing Shake and Spill. I'd like you to notice how they use both counting and subitizing as they engage in this activity. Let's go ahead and watch the video.
Okay, shake, and 1, 2, 3, spill. What do you notice now?
I have 3 yellows and 4 reds, and he have the same.
And what do you have, Liam?
3 yellows and 4 reds.
And how many do you have all together?
7.
And Gavin, how many do you have all together?
7.
7. Okay, go ahead, gather them up. And
I got them up.
All right, ready? Shake, and 1, 2, 3, spill. That's all right, just pop it up. All right, what do you notice?
Oh, we keep getting the same.
That is crazy, you keep getting the same. What do you notice?
There's 5 reds and 2 yellows.
And how many all together?
7.
And what do you have?
The same.
So some noticings. Hopefully you noticed that Liam and Gavin just naturally made subgroups with those counters. They were able to subitize the size of those subgroups. You probably noticed that Liam used counting to find the total, whereas Gavin mentally combined those subgroups. And Gavin also saw 5 in different arrangements as he compared his counters to Liam's. So in thinking about these young learners, I want you to keep in mind that subitizing is developmental. Julie Sarama and Doug Clements have mapped out developmental learning trajectories for children in several areas of early math. Shown here is the subitizing learning trajectory. For this learning pathway, they've identified 12 levels or milestones in children's thinking. This progression shows how subitizing grows within children from birth all the way into 3rd grade. The trajectory maps out how toddlers begin to recognize and name small quantities. Next, children use perceptual subitizing for sets of 4 and 5 objects. Then children engage in conceptual subitizing to name quantities to 5, then to 7, then up to 10, and then up to 20. Subitizing also supports place value understanding and even multiplicative thinking. One thing that's really important to note and remember is that children's movement along the trajectory is not automatic. It hinges on instructional experiences. Let me say that again. Children's progress along and through the trajectory occurs only through engagement with appropriate and intentional learning opportunities. Okay. Here you see a collection of dot arrangements that I've found useful in my own work with children and with teachers. This set includes arrangements of dots from 0 to 10. We're going to watch a video clip from a 1st grade classroom in which the students have had many opportunities to explore and discuss these dot arrangements. The teacher has been very intentional in pressing students towards subitizing rather than counting the dots by ones. So let me introduce you to Finley. It is about midway through the school year, and she is being asked to subitize the set of dots you see her on the screen. Let's listen into her reasoning for the set of dots. Let's go ahead and watch the video.
7.
And how did you see 7?
3 and 3 and then 1 in the middle.
Okay, can you show me on the pattern where you see it?
So 3 here and then 3 here and then 1 here.
And how do you know that that's 7?
Because 3 and 3 is 6, and then if you add 1 more, it's 7.
Finley was very confident in her response to 7 and clearly explained how she was seeing and thinking groups and subgroups. Another tool, which you see here, is a 10 frame. It can also be used to support students' progress along the subitizing trajectory. This tool provides a structure for anchoring numbers to 5 and to 10. Here's an example with 8 dots. As you can see, in the 10 frame, children will notice that 8 is 3 more than 5, and also that 8 is 2 away from 10. To further extend children's work for numbers up to 20, we can use a double 10 frame. Let's add some dots. Here we see 9 dots on the top frame and 5 dots on the bottom frame, and the question we would ask children is to figure out how many dots in total. Let me introduce you to Will. Again, it's about midway through the school year, and he has been asked to figure out the total number of dots on those 2 10 frames that we just looked at. So let's listen in on his thinking as he adds 9 dots and 5 dots. Let's go ahead and watch the video.
What do you think?
14,
How do you think you saw the 14?
9 and 5, and if you took 1 away to the 9, it would be 10, and 10 and 4 is 14.
Okay, let me show this to you, and then I want you to talk through your thinking again.
9, so if you took away that one, it would be 10, and then you still have 4 more to make 14.
Isn't that spark in his math reasoning just delightful? When the dots were hidden, Will was able to hold those quantities in his mind and work with them flexibly as he broke that 5 apart and then put the numbers back together. Something really phenomenal is going on here. Will is actually learning his basic addition facts. So let's think about this connection between subitizing and learning our addition combinations. Conceptual subitizing provides a direct experience with additive situations as children are conceptualizing 2 parts in the whole. And having both parts and whole in working memory is in fact what builds a foundation for knowing addition facts. All right, let's think a bit more about subitizing and consider how it is actually the on-ramp to deeper knowledge of number. This includes being an on-ramp to stronger and more fluent learning of basic number facts for addition and subtraction. It's also an on-ramp to number sense. Okay, so reflect for a moment. What happens with counting? With counting, students are encouraged to see and think once. With subitizing, children are encouraged to see and think groups. And it's seeing those groups that builds a stronger foundation for learning our addition and subtraction combinations. And in fact, it's that ability to see and think with groups that accelerates children in their learning. Let me say that again. Subitizing is the on-ramp to accelerating children's learning in mathematics. I'd like to share this reflection with you from a special education teacher with whom I was working. She commented, "I now realize how important subitizing is for my students. and how, when not developed in children, leads to struggles in math as students progress in school. Using dot patterns helped my students see and visualize quantities and helped move them away from always counting by one every time they add numbers. The point I want to make here is that subitizing is important for every child and that it benefits every child. I mentioned that subitizing is also an on-ramp to number sense. NCTM states that a hallmark of number sense is flexibility in working with numbers. And this flexibility only develops through learning environments that value multiple strategies and diverse ways of solving problems. And this type of work begins with subitizing. Francis Sue has said, at every opportunity, we need to counter the idea that math is memorization and replace it with the idea that math is exploration. In fact, this focus on memorization in math is a practice that we need to disrupt and dismantle in our schools, and we need to replace it with more opportunities for children to find wonder and joy in exploring quantities, which can be achieved through subitizing. NCTM also points out that children's number sense can become stronger or weaker over time as a direct result of their math learning experiences. Number sense is not something that just happens, but something that we must be intentional in developing in children, and subitizing is a great place to start building that number sense. Furthermore, NCTM notes that this overemphasis on rushing children to memorize basic number combinations or algorithms can halt children's sense making, and as a consequence, they miss out so much on the satisfaction and enjoyment in learning mathematics. We are going to watch 2 more video clips of students that were recorded at the end of the school year. They have been learning in a classroom that prioritizes subitizing and have been using dot arrangements and 10 frames all school year. This is Hannah. Let's listen in on her reasoning as she solves 8 plus 5. Let's go ahead and watch the video.
Hannah, could you solve 8 plus 5, please? Okay, and how did you get the answer of 13?
I just subtracted the 2 from the 5, and then I had 3 left, and then 8 plus 2 equals 10, and then 10 plus 3 equals 13.
How delightful. Hannah quickly wrote down the answer of 13, and then she confidently explained how she broke apart 5 and then recomposed those numbers to find the total. This is just a direct result of her work on subitizing throughout the school year. Okay, this is Darcy. Same classroom. Let's listen in to Darcy's reasoning as she solves that same problem, 8 plus 5. Go ahead, let's watch the video.
Darcy, what is 8 plus 5?
8 plus 5 is 13 because if you add 2 from the 5 to the 8, it would make 10. And then if you add 3 more, it would make 13.
How delightful. Just confident, great flexibility in working with quantities. I mean, this is what we want for all of our children. Both Hannah and Darcy demonstrated a strong foundation of number knowledge that has emerged from an emphasis on subitizing and sense making in their classroom. So to close, let's recap some key takeaways. Why focus on subitizing? Well, subitizing is an essential but underappreciated skill in number development. Subitizing is about thinking in groups, not ones. It is playful and joyful for children and exploring quantities. It's the on-ramp to flexible addition and subtraction strategies, and is the on-ramp to number sense. So to close, subitizing is foundational in aiming for deeper learning of mathematics, and that is the opportunity all children deserve. Thank you. Hello, everyone. Thank you for joining my session today. If you have specific questions or comments, I strongly encourage you to just put them in the chat. I'd be happy to respond to any specific questions you might have as you reflect back on really pushing and supporting our younger learners towards deeper learning in mathematics. While you perhaps are typing or thinking about what you might want to ask, I was just kind of reflecting on the session myself and got thinking about, how can we bring more joy into our students' classrooms? It's so sad when we have our young learners already like thinking, oh no, I don't like math, or I don't get it, or I don't understand it. And part of that is because we push them to memorize things that don't make sense to them. If you understand something and understand it deeply, that is joyful learning, that understanding. So I think about, joy comes from working with your peers, sharing your thinking and reasoning, being encouraged to kind of see these quantities in different ways, or any work they're doing in math. It comes from making connections among those mathematical ideas. It really just comes, that joy comes from deeper understanding. All right, I see some questions coming up in the chat. Yeah, I love the word decompose, because that is in fact what kids are doing when they're subitizing, right? That I think it transcends a lot of strategies. In fact, when we start thinking of 2-digit and 3-digit computation, or even multiplication, decomposing, again, I think is kind of an essential skill that we want to encourage children to do. But again, we want them to do it in a way that's flexible and comes from their understanding and their exploration of those quantities. All right, let's see another question here. Ooh, subitizing with fractions. Oh, I love fractions. I could do a whole nother session on that. I don't know if you're familiar with some of the different fraction images and things that are out there. You can easily Google them and find them on the web. But yeah, we can do subitizing with fractions. And, whether some people might say we're really just doing visual problem solving, but we can also look at and think about, as long as we have the whole defined, then students can think about what parts or what wholes or what multiple wholes are represented by quantities. So yeah, like I said, you can Google images for fractions and find some examples. All right. Feel free to add more questions. I was also reflecting on just the power of subitizing that we just naturally see in children, and that they begin to naturally use these number relationships. I've heard Doug Clements kind of talk about this one study where we can actually teach subitizing out of kids. We should celebrate that, wow, you see 3, you see 4, and we shouldn't always make them go back and count things by ones. We should respect and value that they see these quantities and that they can start to work with them. And maybe this last thing to share while we have a little bit of time yet is just, what's the rush? Why are we in such a rush in mathematics, right? We rush children into memorizing when we know the development of number combinations, number relationships is something that really happens slow and steady, right? To get kids to go from direct modeling to counting on to really working with those number relationships that then can be accelerated through the work of subitizing. So I just ask you to ask yourself that. What's the rush? Are we giving children the time they need to explore and to develop a deep understanding of number relationships? As Francis Sue said back in that quote, math is about exploration, not about memorization. And part of my fear is when we think about, oh, we got to accelerate children, we have to push them, to catch up on this learning. The rushing and the memorization is not the way to get there. It's deeper learning and deeper understanding, particularly with a focus on number relationships and counting with cardinality in the younger grades. All right, just checking to see if there's any other comments in the chat. Hopefully you are in an environment that already has welcomed subitizing into classrooms. I just know it's so much fun for teachers and students to start working with number relationships and quantities, as opposed to some of the memorization that perhaps occurs too often in classrooms when children aren't ready for it. You can see Hannah and Darcy in the video. I mean, wow, they were so confident. And that was the end of first grade. They knew their facts, but it wasn't through memorization. That was not an emphasis at all from the teacher throughout the year. It was building those relationships slowly over time with dots, with 10 frames, with a lot of conversation and discussion and sharing of thinking and their strategies and sharing ways that they were seeing things. So perhaps then to close, seeing how much time I have left here, I encourage you, if you're an administrator, even to go into classrooms, grab some of those dot patterns, ask children what do they see and how do they see them. I still remember working with a first grader, like we would roll 2 dice, and at first the child had to count them all by ones. Then one day the child could subitize 5 and count on then perhaps the other die, or whatever the number might have been. And I know one day he rolled 2 5s and just said, that's 10. And I was like, what? He started, 2 months ago counting by ones and then moved to counting on. And then all of a sudden he owned that quantity and those dot arrangements and knew what they represented and that he could begin to work with them. So again, it's developmental. I encourage you to go to Doug Clements and Julie Sarama's website to learn more about the subitizing trajectory and to think about how we start children from really those perceptual ideas of seeing groups of 2s and 3s up to groups of 4 and 5, and then that conceptual subitizing. If you recall, there were a whole lot of steps for conceptual subitizing. Conceptual subitizing to 5, then to 7, then to 10, then to 20 and beyond. So at those upper ends of the subitizing trajectory, it was focused on place value understanding. We know that's a challenge for children to really deeply understand place value, and working with those 10 frames and focusing in on quantities can help with that. And then the whole focus on multiplicative thinking. I don't know if you've ever done it, but why not flash or show children multiple dot arrangements like 3 5s or 4 5s and see if they can compose them in different ways to think about and find that total amount. Probably, this is also something to consider in your work and connections to families and caregivers, to also think about encouraging them to have dot plates. That's one of my favorite things to do always is develop a set of dot plates, use those stickers, put them on dot plates and give them to parents and say, take this home. This is what you should be working on with your children, to see those quantities, not just to grab some symbolic numbers that don't have that much meaning for memorizing. So we can really re-envision and we can give stronger tools to parents and families to also help them understand, to encourage children to subitize, to think about number relationships, and to have more fun with their children around quantities, whether it's dot plates or whether it's just anything you see in your world. Ask children, how many? How do you know? How many people are sitting on that bench? How many birds do you see eating those seeds, right? So it's kind of a quick win in working with parents and giving them a tool and some ideas to build this stronger and deeper foundation of knowledge of number that you or we can then draw upon and build upon in our classrooms. Yeah, multiple dot. Someone just put in the chat, love the idea of multiple dot arrangements. Yep, that's another thing you can kind of Google and find lots of different examples. For example, a quick way to do it is not just use one die, right? You kind of progress from 1 die to 2 die. Why not shake and spill 4 die and see how quickly children can think about combining those quantities, right? So they could be the same number or they could be different numbers of quantities. Yeah, I mean, when you start to use multiple dot arrangements, we really are working on multiplication facts. So yeah, into 3rd grade and even beyond, right? 4th, 5th graders. We have the same issue. We rush children to memorize their multiplication combinations when in fact they could be working with dots and multiple dot arrangements and actually have a little more fun with it and to see that, look, they can see those quantities. They can hold those quantities in their mind and they can compose and decompose to find out what the total amount might be. In fact, we should be thinking about subitizing with multiple dot arrangements as really a precursor for having children work on their multiplication facts. All right. As I further think about this deeper learning and the challenge of accelerating children's learning, it's real. We want children to be strong. We want children to be successful in life, in their work in school, laying that foundation for later grades as we think about what goes on in preschool, kindergarten, 1st and 2nd grade. But it's really helping children bring in that joy, bringing in the sense of discovery, of exploration, of allowing them to really have fun with quantities. And notice I keep saying quantities. I'm not saying, symbols, right? In fact, sometimes we bring in those symbols way too soon. And children need more time to explore quantities, to own those quantities, and to hold them in their mind so that they can manipulate quantities, not just memorize, work with symbols. The other thing, too, is to think about your curriculum materials. Do your curriculum materials have in them opportunities for young children to work with quantities, to engage in subitizing besides just counting? And counting is really important, and being able to count with cardinality and understand that a number represents a set of objects is super important. But we can, at the same time, start to introduce children to subitizing and having them do work parallel. If you go to the trajectories website, you'll see the counting trajectory. You'll see the subitizing trajectory. And you can see that they kind of develop in parallel because one supports the other. Both are essential skills for our work with children. I hope you've gotten some ideas to ponder further, some ideas that will lead you to some conversations with your colleagues, with your families, and will lead you to richer and stronger experiences with children and really deepening their number in a way that supports exploration and sense making. So thank you very much for spending this time with me today.